Hello students, we are going to look into the main configuration, the robot configuration that is available. Now most of the industrial manipulators have 6 degrees of freedom. What do we mean by 6 degrees of freedom? 6 degrees of freedom. Degrees of freedom, 3 are in the arm and 3 are in the wrist part of the manipulator. That means the hip, the shoulder and the elbow will give the first 3 degrees of freedom, and the wrist will have 3 degrees of freedom. That will be totally making up the 6 degrees of freedom. So these 3 are given by the wrist. Okay, so right now what we are showing here is only the hip, shoulder and elbow part. The wrist we will discuss after this. Okay, already we know what is degrees of freedom. We will look at the other things. So there are basically 5 kinds of robotic configuration, out of which the first one is the articulated configuration, which is also called as RRR. This R basically stands for revolute, revolute, revolute. That means it is standing for this revolute joint, and the third revolute joint. So the revolute joint, I suppose you understand, the revolute joint is the joint which makes an angular displacement between 2 links. So this is the first link and this is the second link. The angular moment is made by the revolute joint, and prismatic movement is made when one link moves in a horizontal direction with respect to the other, or transverse direction. This is called as a prismatic joint. So this articulated configuration, also called as the RRR configuration, has 3 revolute joints. The first revolute joint is having its axis like this and its rotation is in this direction. Either clockwise or anti-clockwise it can move, but we will always show it in this direction. So this is the base. So this is the body part or the hip region, and to that shaft is attached the second revolute joint. And what is important to note here is that the axis of the first joint, which is shown by this dotted one, is perpendicular to the axis of the second joint. So this is revolute joint, first revolute joint and second revolute joint are perpendicular to each other. So that's why in some textbooks you will find R perpendicular R. And the third, if you look, the third joint, the third revolute joint is actually, let me expand this so that you are able to see it much clearly. The third revolute joint, as shown here, is basically having its axis as Z2. Okay, so here the movement of the shaft will be in this direction. Let me clear the clutter here. Okay. So for this one, it will move in this direction, revolution or revolute joint. The second will make it move in this direction. See, when this is rotating like this whole motor that we see here, this whole motor will rotate in this direction, and then this link is basically going to move up or down, angularly up or down based on the movement of this revolute joint. So that is what is basically this diagram. The third one, the third revolute joint, is again another motor whose axis is in this direction. So you can see that these two, Z1 and Z2, are the two axes of the motor, and those axes are parallel to each other. That's why it is written as R is parallel to the third R. So R perpendicular, R parallel R, or it is known as the RRR configuration. Okay, so you can imagine the movement. See, whenever we are having a motor like this, Suppose we are having a motor like this, the shaft of the motor which rotates, that shaft is basically the axis about which the rotation is taking place. I will put a video for RR car configuration for you to understand how it looks like in real life. Anyway, the work envelope or the area with which it can move can be understood by looking at the top and the side view. So if I look from the top direction, suppose if I look from this direction, what do I see? I basically see this image. Okay, so this is the top one, and its movement is there, and then we are having the work envelope around it. Okay, the work envelope around it. So this is the articulated one, or it is also called as, let me reduce the size, or it is also called as the anthropomorphic manipulator. Okay, and it's actually the Revolute configuration for a large degree of freedom it provides. One of the example is Motoman SK16 is a old robotic manipulator. Okay, so this is the first articulated configuration. The second one is a spherical configuration in which again we have three joints. The first joint is revolute, the second joint is also revolute, the third one is a prismatic joint. See how we draw the prismatic joint. Let me expand it. Yeah, how do we draw the prismatic joint? The prismatic joint is drawn like this. You draw a cube, and then you draw one face of the cube as if it is moving away from the cube, and that is what is drawn here. So here the movement is angular movement of the shaft, which is θ1. The axis of that is Z0. The second revolute joint is having the shaft like this, and the axis of that is Z1, and its movement is around in this direction. And the third movement is prismatic joint, which has this movement in D direction, or the axis of the prismatic is again the direction in which it is moving, and that is the Z2 axis. So this is the revolute prismatic configuration, or also called as the spherical configuration, or RRP configuration. Here again you can see that it is basically R perpendicular to the next R. That means you can see Z0 and Z1 are perpendicular to each other, and Z2 is perpendicular to Z1, so it is perpendicular to P. So in certain textbooks this is also the way it is done. Now if you would try to find out, let me rub everything off. If you would try to find out what is the, what are the different areas where this particular end of this one can go, that is called as the work envelope. So you can see that the work envelope of a spherical configuration will have this kind of a, see it's not exactly this, you can say it's a spherical configuration, they have not completely drawn it. It can move in a spherical way around it. Another, a very famous, example of spherical configuration is something that is called as a Stanford arm. The Stanford arm basically has, as you can see, there will be one motor which rotates this in this direction, that is given by this θ1. The next angular movement is given by this small, movement here, which gives it a angular movement, and then finally this extension will make it the prismatic movement. And that same thing you can see here. Here this will move in this direction, this hip will move in this direction. Here this arm can move in an angular fashion up, or it can move down based on the joint that is here. So this is a revolute joint, this is the second revolute joint, and the third revolute joint will be by moving this one front or back. The end of this one is moved front or back. This much part might be the wrist, which I am not drawing here. This much part might be the wrist. Okay, so we are only interested in the first three joints. So that is the spherical configuration. So this is the spherical configuration. Next we will go for, let me zoom out. Next we will go for the next one, which is the SCARA manipulator. In SCARA manipulator, again, what we find is that the SCARA manipulator also has three joints. First one is the revolute, the second one is again revolute, and the third one is prismatic. So again it looks like RRP, just like the previous spherical one, RRP, but this is SCARA. SCARA basically stands for Selective Compliant Articulated Robot for Assembly. This kind of robot is basically for assembly operation. It is a very popular robotic configuration, the SCARA configuration, because it can do a lot of work on a tabletop. So here what difference you find is that there is this link which has a 90-degree bend. The link has a 90-degree bend here, which makes the first and the second revolute joint have a parallel axis. So what is the first axis of the first joint? It is this one. This is Z0. That axis and the second axis are parallel to each other, and also the third axis of the prismatic joint, that is also parallel. So all these are parallel. So in certain textbooks it is written as R parallel with R parallel with P. Okay, and this kind of a robot, if you would see its work area or work envelope, what you will see is with its movement it creates this kind of a work volume. So whatever is inside this volume can be operated by this robot. Okay, so it looks like a disc, it looks like a cylindrical disc. But what is not possible here is, what is not possible here is you cannot move this one in this direction. You cannot move this one in this direction. You can only move it up, down, or you can have spherical rotation. Because of that, obviously with that spherical rotation we can move anywhere within this configuration. But so you can see this is basically how the robot looks like. So it has the first joint here, the second joint is here, and the third joint is again here. They have shown it as a revolute one, but that is when there is a third joint. But basically for us it is only having this joint. Okay, these three joints, first, second, and the third joint. Now what it has shown here is also having the wrist part, which we are not interested in now. This is how it looks like. One of the very famous SCARA configuration is this Epson E2L653S. That is the SCARA configuration. Let us come down. Let us go to the next configuration, which is the cylindrical configuration. In cylindrical configuration, as you can see, let me expand it. As you can see here, you are having a first revolute joint, the second is a prismatic joint, and the third one is again a prismatic joint, giving it a RPP configuration, or also called as cylindrical configuration. Why it is called as a cylindrical configuration is because its coordinate will come as a cylindrical coordinate system. You might not be knowing what is cylindrical coordinate system, but right now I will not teach you that. So what we are having in the first is first and the second, if you would see, they are parallel and collinear. That means the axis of Z0 and Z1 basically are on top of each other. They are parallel and they are collinear. Collinear means lying on top of each other. So what we are having for this thing is, we are having a prismatic joint here, we are having a revolute joint here, and the axis Z0, Z1 is same, and Z2 is perpendicular to Z1. So it basically is R parallel with P, perpendicular with P. So as you can see with this one, this point, it can move up and down with this prismatic joint. It can move front and back with this prismatic joint, and it can move anywhere around with this particular revolute joint. So it is having movement up and down and anywhere around, and that's why if you would see the workspace or the work envelope of this cylindrical configuration, it will have this kind of a cylindrical shape. Okay. For the examination, you may have to draw this one as well as the work envelope. So be careful. Okay. Another diagram which basically illustrates the same one is this one, and this is one of the examples. It is a Seiko RT 3300. Okay, so like that, this is the configuration which is called as the cylindrical configuration. The last one is the most simplest one, which is the Cartesian configuration, which has three prismatic joints: P prismatic, prismatic, prismatic. One is moving in, suppose this is the x direction, the other one will be moving in the y direction, the third one will be moving in the z direction. So basically, if you would go for an XYZ axis, these three joints will move anywhere in the XYZ axis. That's why the work envelope is always a cube. It's always a cube. See, this kind of a Cartesian configuration is very much used in for heavy weight lifting of things. This is called as also as a gantry robot. It is also called as a gantry robot. So basically, as you can see here, or you can see here, these joints basically move front and back, because of which this whole setup moves front and back. And this third joint makes the arm move up or down. So gantry robots is mainly used in heavy equipment lifting or heavy duty lifting. If you would look for, you might have seen big cranes in shipyards, which basically takes big cranes in shipyards, which basically move on top of rails. So there are rails like this, it moves on top of these rails, and there is a hook that is hanging from top. There is a hook hangs from the top, and this hook is used for lifting up things. Okay, and that is basically a gantry robot. And the gantry robot basically has this Cartesian configuration, PPP configuration. So these are the 5 very important robotic configurations that are used for designing the robot. So once again, I will take one by one. The first one was the articulated configuration or RRR configuration. The second one was the spherical configuration or RRP configuration. The third one was again RRP, but this time it is Cara configuration. The difference is this 90-degree bend brings all the 3 parallel to each other. Okay. The previous one, it was not the case. In the previous one, the 3 are perpendicular to each other. The 3 axes are perpendicular to each other, because of which we are having a total different setup. Next is the cylindrical configuration, which had RPP configuration, and the last one was the Cartesian configuration, which was PPP configuration. Here in certain textbooks, PPP is also written as P perpendicular to P perpendicular to P. Thank you.